Let me share this screen over. All right, so these properties of logarithms are going to help us solve the equations when we hit 9.6 next week. I'm going to list all my properties and then I'll do examples going through each of these properties, okay? So first property, product rule of logarithms. I'm just going to abbreviate that logs today. And these log properties sort of follow your exponent rules that you might have had in the past. Because remember, logarithms are really exponents in the long run, okay? So product rule says if I got a log of a product, I can rewrite that as a sum of the logs. So that could be log base A of M plus the log base A of N. And I remember that because when you multiply variables, you add the exponents. So that's basically what we're looking at. Exponents of a product are being added on those, okay? Second, we got what we call the power rule of logs. So the power rule deals when you have an exponent raised to an exponent. So this would be like the log A of M raised to the P. And in the real world, when you had an exponent raised to another exponent, you multiply them. So what we do here, we bring the P down to the front and multiply by the log base A of M. And when you do these, you don't actually have to write the multiplication about like I did. It'll know that it's a product when you put them in there, okay? So basically, anytime I got an exponent up there, I'm just going to bring it down to the front of my expression. Third one deals with the quotient rule of logs. So the quotient rule deals with division. So if I have log base A of M divided by N, we write this as a difference of the logs. And I do that when y'all had x2 over x, you subtracted those exponents, okay? So this would be the log A of M minus the log A of N. Now there's one more thing that'll really help you in this section. Anytime you get something that looks like this, a log base A of A to the X. In the long run, this equals the X. Because what I'll do, I'll bring that X down to the front, like my power rule says. It'd be X times log A of A. But the log A of A equals 1. Anytime this base matches that result, that logarithm is going to give you 1, okay? So that basically becomes what, an X times 1, which gives me an X. There's a few problems where you're going to have to remember this, okay? And I'll show you those when we're going through them. So I'm going to do examples of each of these rules. And then they turn it up and combine them a little bit, okay? So these ain't bad. These ain't bad. Just Just keep up with this, these little rules right here, and you'll be good to go through this homework, okay? So the first couple problems wants me to express as a sum of logarithms. Let me look at these. Now, these properties I just gave you, only one of them has anything being added. So it's going to be something that looks like this one, okay? So they're giving us, for number one, log base 22 of 22 times 484. So that's basically written like this, log 22, m and n would be the 22 times the 484. So all we're going to do is distribute that log 22 to both of those and rewrite it as a addition. So I got log 22 of 22 plus I got log 22 of 484. Now, the trick on this, whatever the log base is here, both of these have to have that same log base of the 22 on them, okay? And then you just separate the factors out by the add. So what we did on these problems, we're going to have one with log and one with the LN. Oh, that's done on that. All I had to do was rewrite it as addition, right? That's all they wanted me to do, express it as a sum. That's what I'm saying. If you got these rules, tattoo these on your arms if you got to. Okay, there we go. All right, let's try one for LN. LN of B times C. So I want to distribute the LN to both of those factors and rewrite it as addition. So I get a LN of B plus the LN of C. And that's it. So you expected more because we just went through chapter 8 with all that pulling and all that synthetic division and all that. So you are thinking, oh, these problems, no, some of these, they will out, some of these later are a little bit trickier. Express as a product. Well, the only one that has any products being expressed is this power rule. Well, we wrote them as a product when we were done. So we're going to express as a product. So this will be like y'all number 3. So I got a log base 10 of x to the 15th. Now, I'll tell you the truth, they didn't have to have this in parentheses, but for some reason they did. Probably just to show y'all where it was being separated and stuff. But this power rule only has me do one thing, right? It wants me to take that exponent and bring it down to the front. And that's all it wants me to do. So what I want to do is bring this 15 down to the front, so I get 15 times the log base 10 of x. And guess what? That's all I do to that. So they'll say the first 6 of these are fairly like one step. Then they start jumping them up, okay? So y'all good so far? So now they got an LN. Now this might be tricky to you. LN, the 4th root of 6. So I'll tell you what might get y'all is you got to be able to convert these radicals into fractional exponents. So let me just say this. Recall to rewrite a radical as a fractional exponent, you take the base, which is under the radical. You're going to make a fractional exponent. On top is the exponent, which would be the m The bottom of the fraction is the root of the radical, which would be the n. I'm doing that with this problem right here. So I'm going to bring this down, ln. I'm going to take the 6 and then rewrite my radical as a fraction. Guess what? The 6 does not have an exponent by it, right? It's automatically a 1. Good job. So if you don't have an exponent by that number, it's going to be a 1 on top for sure, and the bottom will be the 4. So you got to go to rewrite that radical as a fractional exponent. Once you do that, I've got one move. Let's take that exponent and bring it to the front. So that I end up with a 1/4 times the ln of the 6. Now, you're going to get good at doing these radicals because I think there's like 3 or 4 problems where I'm going to be changing them radicals over for you. Okay? All right, question on those? So guess what? The next ones will have me write them as a difference of logarithms. So express as a difference of logs. So this is what, number 5? Log base R, so log base R of D over 3. Now, we'll say this, in MATLAB, on these problems, if they use a capital letter, you better use a capital letter, and then if they use, what do you call lowercase letters, then you got to use lowercase letters, okay? It will mark those wrong, and then these are small or big, and they need to be the opposite, okay? All I'm doing is this. And it's always the top minus the bottom on those, okay? So distribute the log R to both of these. So you get a log base R of D minus a log base R of 3. It's rewritten as a difference, so we're done. Wasn't y'all ready for all that math about the numbers, right? Well, I'll tell you what's tricky about these is I doubt they even show y'all these in high school at all. I can't remember no high schools where I ever did logarithms, unless y'all might have been in, do they still do like pre-calculus type classes?
That was almost 20 years ago.
Yeah, me too. They didn't do all that in the 80s either. The ones over there had pre-calculus and they looked at this kind of stuff. Algebra 1, algebra 2, you're not looking at logarithms probably. Okay. All right, so 6, they'll probably do with the ln, so let me see what they did here. I got ln of a little m divided by a little t. Well, that should be pretty quick, right? Top minus the bottom, so it's going to be ln of m minus ln of t. So those 6 problems, we're just getting y'all used to their little properties, okay? Then they come along and said, well, let's rewrite as sums or differences of logs. So we're going to rewrite as sums or differences of logs. So this is all rules apply. All 3 of them properties are now in effect, okay? All right, y'all, we're going to start out with ln, parentheses, x to the 4th, y to the 6th, times a z. So the first thing I notice is this is a product. So to rewrite the product, it will be addition. So let's distribute the ln to everybody. So we get a ln of x to the 4th plus a ln of y to the 6th plus a ln of the z. So the only way you're going to get subtraction is if you got division going on, okay? Now, that's rewritten as a sum, but there's one more thing I got to do to all of these. Can you figure that out? Think about rule 2 I gave y'all. Rule 2 was the power rule. Yeah, we'll move these two exponents to the front of their logs. So this 4 has to come down and the 6. So when you're done writing logs, you cannot have exponents sitting up on them variables, okay? So this becomes 4 times ln of x plus 6 times ln of y, and then at the end is still my ln of z. Now all the exponents are down, it's rewritten as a sum, and they're happy, okay? Y'all good on that? All right, here's one of the first tricky ones. I got a log base b. On top, I got a p to the 4th, q to the 5th, all over, m to the 3rd, b to the 9th. All right, so here's the trick. If they're on top, the top we rewrite as positive. If they come from the bottom, they will be rewritten as negative or subtraction, okay? So remember, when you do this, the top's always going to be positive and added. The bottom's always going to be subtracted or negative, okay? Distribute this log b to all 4 of those. So you're going to have a log b of p to the 4th plus log b of q to the 5th. So those two are on top, we kept them positive. Everything else is on the bottom, and they're going to be rewritten negative. So minus log b of m to the 3rd minus log b of b to the 9th. So the rewritten now with sums and differences, but I still got to do something else. Move all the exponents. Now there's one I'm not going to move the exponent on. And that's this part right there. I gave y'all a star while ago when I gave y'all them properties. And I said anytime these bases match those results, the answer is going to be the exponent. So that part there is just going to be a minus 9. Okay? Everything else I'm going to come down and do what you said, bring all these exponents to the front. So I get 4 log b of p plus 5 log b of q minus 3 log b of m minus 9. So there's a couple places where we're going to hit you with something like that log b of b to the 9th, where you just get the exponents on those answers. Nothing else I can do to that, so we done. So you notice the trick on these logs? They don't get smaller really. All you do is rewrite them and changing them around, but they don't get smaller like when you're doing equations and stuff. So you're always writing a whole long sentence each time. But so questions on that? So the thing about it, watch out for this, okay? if you put -9 log b of b, it probably tells you something like, hey, you got the right answer, but you're not in the final form or something like that. Drawing number 9, we got ln. ln of 2 divided by 9x to the 9th y. Once again, when I rewrite it, if it's on top, it's positive. If it's on bottom, it's negative. So here we go. I'm going to do ln of 2. So here's a question for y'all. How many factors do y'all see on the bottom of this? 3. Got a 9, the x, and the 1. I'm just asking y'all that because some of them earlier were treating the 9x as one factor, which was sort of freaking out the math a little bit, you know. So there's definitely 3 factors that are being subtracted on the bottom. So it'll be minus ln 9 minus the ln of x to the 9 minus ln of the y. Oh, and one more thing to do. And sadly, you got to do all this work just because of that 1 9. So here we go. ln of 2 minus ln of 9 minus 9 ln of x minus the ln of y. Now, let me fix y'all real quick. When you punch in this ln, that is not an in. If you punch ln, it'll make it bold and dark. So you know you got the right thing. If you do an in, like a capital I and an N, it won't bold it and highlight it. So it's going to mark it wrong for sure. ln, not in, okay? For, I guess it means log natural. So that's where I get some of the people be, oh, I got this right, and I'll go back and look at it, and they highlight it because they put an I in. I have the test that probably fix that for people, but homework, I ain't got time for that, right? Oh, y'all, let's see, 10 log square root of a C6D. I'm going to turn that square root into a fractional exponent. But notice, since you got 2 things under here, I'm going to put them in parentheses and then make my exponent. So my question is, what's the exponent? 1/2. Perfect. So if you said 1/2, remember, a radical without a number in it was automatically going to be a 2, okay? So now, exponents, the D has a 1 by it since it don't have an exponent. And what you're going to do now is multiply these inside exponents by the 1/2. So you get a log C. So what is 6 times 1/2? Or 1/2 of a 6? So you get a C3. And the D has 1 times 1/2. So that's going to stay at 1/2. Now notice, I ain't done nothing to this problem except for getting rid of that radical. Now, they're being multiplied, so we're going to write them as addition, right? So we're going to have a log C to the 3rd plus a log D to the 1/2. And your favorite move? Pull all those exponents down to the front. So I get a 3 log C plus a 1/2 log D. So the trick on these is just get used to these letters. And making sure when they do have the little bases, that you make the little bases go everywhere, okay? All right, clicking on that. But I got a good one coming up. So they took this problem and put it on steroids for my next one, okay? Hang on. So this is what, 11? So y'all watch this. They got log base C, and then big parentheses with a big radical with a 4 on it. Look the fourth root. Underneath is an M8, N20, over C7, and an A5. So y'all will tell you the truth. The first few steps of this, all I'm going to do is get rid of that radical in the very beginning, okay? So let's get rid of the radical. So we got a log C, M8, N20 over C7, A5, all raised to what exponent y'all putting on that? 1/4. Because I did next to the 4 on that, okay? And I'll tell y'all, most of these, y'all just want to be putting a 1/4 for 1/2 or 1/3 or whatever they got, okay? So now this looks like this, and I'm going to distribute my exponent to everybody inside these parentheses. So bring down your log C. If you notice, I'm still just doing the part where I'm getting rid of the radical, right? And rewriting them. So what is 8 times 1/4? It's going to give me an M squared. So here's the trick. When you multiply a number times a fraction, you're just basically taking the number and dividing by that bottom. So how about N? I had N20, so 1/4 of a 20 would be 5, so they give me 5. Now, sadly, these ones don't divide by the 4, so you're going to have to write them as fractions. So C, 7 times 1/4 would be 7/4. A, 5 times 1/4 would be 5/4. Okay? Now remember, if you don't like multiplying fractions, you got that fancy calculator, it'll knock them all out for you. So all I've done was rewrite it from the radical at this point to this. Now, if they're on top, they're going to be positive. On the bottom, they're going to be negative. So I've got a log C of M squared plus a log C of N to the 5th. Both those are on top, so they're positive. These are on bottom, so they're going to be negative. And notice, all we're doing really is distributing the log to everybody, okay? So minus the log C of C to the 7/4 minus the log C of A to the 5/4. All but one of these we're about to do something to. One of these is going to follow. Oh, did I have, oh, this part right here? Log B of B to the 9. Look at this. That's a log C of C to the 7/4. So that's just going to equal what? The 7/4, okay? So the rest of these, bring the exponents down. So you get a 2 log C of M plus 5 log C of N minus the 7/4 minus 5/4 log C of A. So like I said, pretty much you're done at this step other than bringing the exponents down and taking care of that. Anytime them bases match those results, you got to make that exponent only, okay? So then we go the other way. So let him catch up. So what we're gonna do now is take many and turn them into one. So everything we did this way, we're going in reverse, it looks like, right? But going in reverse is what's gonna help us when we solve these equations. Because we want to turn two logs into one log on those, okay? Here's this tricky, just keeping up with signs on them. And these bases, you gotta make sure these bases. And now this is to put in MATLAB because you gotta do the two log, then you gotta finish the subscript to do the C, and then go back up and always have to hit them little subscripts on them. And there's one that had fractions that was ugly answer. When I hit number 14, I think it is, you're gonna be doing a lot to that one. Okay, so basically, them last 5 problems was just rewriting that sums and differences. These next few, or the rest of these, we're just going to express as a single log. Which means if they're being added, I'll write them as a product. If they're being subtracted, I'll write them as a quotient. If they got numbers in front, I'll move them back up to be exponents. All right, number 12 has a log base C of 67 plus a log base C of 5. So this one, they're being added, so I write it as a product, log base C of 67 times 5. And actually, in MATLAB, they want you to multiply that out and finish it up. So this would be a log C 67 times 5. 335. So I get a log C of 335. Okay. And now watch this one. This one says express as single log. And then simplify it. So this is basically going to have two answers. They want you to write it as a single log, and then if that simplifies any further, do that, okay? They're giving us log of 100 minus the log of 10. So y'all see that's negative on this one, so it's going to be written like a fraction. You're going to bring out that log. Top of that fraction will be 100 because that was positive. The bottom will be the 10. But y'all can work that further, right? Log of 100 divided by 10 would be the log of 10. That's the first answer MATLAB wanted. Can y'all simplify that log 10 further? Now remember, since there's not a base here, it is a 10 sitting there, okay? So y'all got a log in front of that calculator, punch log and put a 10 in there and see what you get. What'd you get? Are you finding that log in front of this thing? Oh, right here. And then put in your 10. And then enter. And that log 10 did turn into a, where's that, right here? So, put in the log 10 for the answer, then it says, does it simplify further? Then you put in the one to be done. Okay? So this simplifies to 1. Okay? And you know, that's the only one, number 13, you had to do any more simplifying to, okay? Everything else, when we stop, we're done. And I really think they want you to realize that 10 to the 10 is a 1, just like the B to the B was a 1, and C to the C was a 1. That's why all those were equal in the exponents when y'all were doing them, okay? All right, same thing here, 14. 1/3 log C of X plus 5 log C of Y minus 4 log C of X. First thing I'm going to do is the last thing I did the other direction. So the first thing I'm going to do is take all these exponents and move them up. Okay? So that I get a log C of X to the 1/3 plus a log C of Y to the 5th minus a log C of X to the 4th. So bring all them exponents up. Now, if they're positive, they're going to be on top of your fraction. If they're negative, they're going to be on the bottom. So let's pull the log C out. On top of my fraction is an X to the 1/3 and a Y to the 5th. The bottom is the X to the 4th. So we're almost done, but y'all, one thing I cannot have in fractions is X's over X's. Anytime you got X's on top and X's on bottom, they will simplify. So what you got to do on this problem, to simplify those X's, you subtract the smaller X from the larger X and leave the answer where the larger X was. So 4 is bigger than 1/3, right? So on top will only be the Y to the 5th. The bottom will be the X's, but I got to figure out what is 4 minus 1/3 going to give me. So y'all can play some on your calculators. But basically, you got 12/3 minus 1/3. So what did y'all get? 11/3. Now, this one's a tough one to put in the math lab. Because you got to hit the fraction first, put this Y5 up here. When you go to the bottom and put the X, that is a fraction. You got to put it in as an exponent, though, okay? So at the bottom, you got to hit the box with the little blue box to the right top of it. Just remember, if you got to this point, it would probably tell you your answer is not in the right form, which means they want you to go on and simplify that down, okay? So questions on these yet? I only got 3 more to go. They're not too bad if you keep up with that first page I gave y'all with the first few properties on it, you know. All right, 15 is a tricky one. Go see what y'all do on this one. 15 has an ln of x to the 6 minus 3 ln cube root of x to the 5th. So this is the last one I got to worry about a radical on. But y'all, the first thing I'm going to do is get rid of that radical. So I'm going to rewrite this and get rid of the radical. So I got ln of x to the 6 minus 3 ln. Can y'all figure out what this fraction will be? 5/3. Good job, because this one did have an exponent by the x, right? So the exponent automatically goes to the top and the index to the bottom. All right, so watch what I'm going to do next. Next, I'm going to bring this 3 back up here. If you move the 3 up, it's going to get multiplied by what's already there. So I got an ln of x to the 6 minus ln x. This would basically be 5/3 times that 3 y'all brought up. Well, guess what happens to the 3's? Y'all, these 3's are going to cancel out. So I get an ln of x to the 6 minus ln of x to the 5th. So all that basically all we're doing was moving that exponent back up and getting rid of that radical. Now, they're being subtracted, so they're going to look like division. So ln x to the 6 is on top over x to the 5th. Uh-oh. I got the same thing happening I had here, right? X's over x's. So what you want to do? You're going to subtract the top one, well, the bottom one from the top one, because this time the big one's on the top. So 6 minus 5 gives me an x to the 1st, which means I don't even have to write that exponent. Because it's automatically understood to be a 1 by that x. But it ain't gonna lie, there's a couple tricky ones in here, okay? All right, y'all, this is, I love these ones right here, but we'll see how y'all like them. ln of x squared plus 10x plus 24 minus the ln x plus 6. So they're using parentheses on these because they got more than one terms following them ln's. But since these are being subtracted, I'm going to write them as a fraction. So bring out that ln. Top of your fraction will be the x squared plus 10x plus 24. Bottom of the fraction will be a x plus 6. And I don't have to use fractions when I'm in parentheses when I'm in fraction form, because the math lab knows that the top of the fraction and the bottom are technically in parentheses. But y'all, we're not done. I need to see if that fraction will simplify. And the only way to tell if this will simplify is I got to take the top of this and factor it. I know the bottom don't factor because it's just an x plus 6 down there, okay? X squared plus 10x plus 24 will factor. And if you're weak at factoring, I gave you all a factor program, I think. Let me make sure. Program, yeah, factor number 7. So what you do it just like the quad. I got 1, 10, and what, 24, which puts you into ABC. It'll factor it right down for you. Now by hand, you got an x and an x. Last side's positive, so both of these will be positive like the middle number. Factors of 24 that add to get 10 are 4 and 6. So did you have that program on there, or do I got to put one on you?
No.
Yeah, perfect. So I did all that because I wanted to do one thing to this. Anytime a factor on top matches a factor on the bottom, you cancel them out. So these x plus 6's cancel each other out. My final answer is the ln of parentheses x plus 4. So since there was nothing else to determine that those factors went together, you got to keep them in parentheses because that ln applies to all of that, okay? That's it. Actually, on that one, number 16, the A, B, C, D choice. So they got that over, okay? Now, I will say this, if you are weak at factoring and you don't have the factor program, use the quad on this. Quad would have gave you a -4, -6 as the answers. So when you put them in factor form, you change the signs. And y'all remember that because y'all had the FOIL about 20 times in 8.3, I think. And you had like X was 4, but when you put it in factors, it ended up being X minus 4 type stuff. So that's where those are coming from. Well, my last problem has a log x squared minus 5x minus 14 minus log x squared minus 4. So really, same thing going on. I'm going to write it as a fraction because I got a positive and a negative part. So I got a log top is the x squared minus 5x minus 14. Bottom is x squared minus 4. Now, if you factor that bottom one, the middle number will be 0 because there's not an x in the middle, okay? So y'all, both of these will factor. And I'll tell you what, both of these are negative on the end, which means all these will have unlike signs on my factors. So how about factors of 14 that equals 5 when you subtract? That'll be 7 and 2, right? Larger number always has a sign in the middle, so the 7 will be negative and the 2 will be positive. We're going to get it on that factor program real quick. The bottom one, x squared minus 4. The middle numbers is 0. What factors of 4 subtract and give me 0? 2 and 2. Uh-oh. Guess what I'm about to do? I'm going to cancel out those x plus 2's. So I get a log. Now, since this one is going to end up with the fraction bar still, you don't have to put these in parentheses. You can do the x minus 7 over the x minus 2, okay? Because remember, it understands now, since that's a fraction, everything applies to that log, okay? So that is 9/5. Now, next class, we're going to solve equations with logarithms and exponential equations. And the trick's going to be turning 2 logs into 1 like that. That makes life a lot nicer if you can combine them into 1 log, okay? Well, Phil, then we ended on that. So, questions on that, y'all? So 9/6 is really the last of the big sections we got. 9/7, I'm thinking about just deleting it and showing y'all the formula, you know, because I sort of make that optional anyway. We had that big snowstorm and all that hit us, you know, so I'll probably do 9/6, 9/7. I might just send y'all videos and just tell y'all about it, but not count it as homework. Because the final exam don't really have nothing out of that section on the final exam. All you got to do is be able to plug into a formula, 1 number, and get your answer on the final. So that's what I'm thinking on that. So y'all hang on just a second. Let me get all y'all people online.
Okay.
Okay, Delisha came in. Brady, I got you. Martin, Yolanda, I got you.
Okay.
And Brenda, I got y'all. So it looks like I got all y'all now. So I'll send these out. I think I sent out a video already this morning from my other class. So I'll send this one, then you got 2 views of it, I guess. Like I said, 9.6 Monday. I'll probably omit 9-7 and just show y'all about it. If any of y'all are doing business calculus, 9-7 would help a little bit, so I'll do that because I want to get a study guide I want to be able to do my test 4 study review next week. And then that next Monday, I want to study for the final exam. Because that's like May 3rd, that Monday, I want to study for it. So your finals will open up May 5th and be due May 7th. So y'all are getting, within 2 weeks, y'all got finals opening up, okay?
Okay.
So a lot of y'all are in good spots. I know you don't like tests, but you still doing good. Still in a good spot, so that's good. So I got a few I worry about because I got people that ain't even took my last 2 tests.
Oh, shoot.
So I'm trying to fire them up, okay? Mhm. So I'll probably be seeing some of them next semester again, you know. Roscoe, I won't be seeing you. You're not having nothing to worry about.
I got to catch up on all this.
Actually, you weren't too bad off.
Yeah, I think I got like 4 I hadn't done yet that was still before the test.
Yeah, because some of them was like support, I think, some of them, I think. All right, y'all, so I'm gonna stop sharing this and I will see y'all Monday.